Hello students, I welcome you all in Kunadana classroom. Today's video, we are going to talk about the third case of motion of a charged particle in magnetic field. So let us see what is the case. The case is this. We have the charged particle having charge q and mass m with a velocity v, but the velocity making an angle theta with the magnetic field, but theta is not 0 degree or 90 degree or 180 degree, because we have seen in case of 0 degree and 180 degree, when the charged particle's velocity was making an angle 180 degree or 0 degree with the magnetic field, the path was straight line, and when the angle was this 90 degree, the path was circle, right? So that's the two cases we discussed. Let us talk about the third case here, where the angle is not 0 degree or 90 degree or 180 degree. This is a general angle theta. Okay. So now let us see what is the case. Here in the diagram, we have magnetic field towards the x-axis, and velocity of the particle is making an angle theta with x-axis, right? So this is a general angle theta now. In that case, what is going to be the path? Let us talk about that. The very first thing that we can do is we can do the component of velocity, and we can say this component is v cos theta, which is parallel to magnetic field. That means v parallel is v cos theta. Okay. And the second thing is v sin theta, that is perpendicular to the magnetic field. So we have here two component of velocity. One is perpendicular, other is parallel. So the parallel component of velocity is basically responsible for giving you a straight line path, and the perpendicular component of velocity is responsible for giving you the circular path. So what is going to be the combination? What is going to be the resultant path? It is circle going ahead. That is called helix or helical path. Okay. So the path of a charged particle is going to be helical if the charged particle is moving at a general angle theta that is not 90 degree, 0 degree or 180 degree. If it is a general angle theta, then the charged particle will make a helical path. Okay. So let us talk about the remaining things here. If you talk about the radius of this path, the radius was m times v perpendicular by qb that we have seen in the previous case. Okay. So this is your radius mv perpendicular by qb. Now what is v perpendicular here? That is v sine of theta. So we can say the radius is going to be mv sine of theta by qb. Okay. So this is the radius of that circular track. Okay. Now let's talk about the next thing, that is how much time it will take to complete a circle, that is time period. So if you look at the time period, it was 2 pi m by qb. This is independent to the velocity. And since it is independent to the velocity, so it is not going to matter that at what angle the charged particle is entering in a magnetic field. If the charged particle is making a circular track, it will take same time, that is 2 pi m by qb. And since time period is same, so frequency will remain same, that is qb by 2 pi m. Okay. But one more thing here we have, that we have to discuss the distance between two consecutive circles. This is called pitch. So we have to discuss this pitch. Let us see what is it. Here we have the distance between two consecutive circles, that is called pitch, right? And what is responsible for giving you pitch? That is the parallel component of velocity, that is v cos theta. So v cos theta is the velocity which is responsible for giving you pitch. And how much time it is taking? It is taking just one time period, one time period means it is just completing a circle. That means it will take just one time period to go from this point A to the point B. So how much time it is taking to travel pitch? That is time period, and that is 2 pi m by qb. So the pitch is going to be v parallel times time. That means pitch going to be 2 pi m by qb times v cos of theta. This is the pitch. Okay, so the conclusion is this: when the charged particle will enter in a magnetic field at a general angle theta, the path will be helical. The time is going to be 2 pi m by qb. The radius will be uh, m times v perpendicular, which was mv sine theta by qb, and the pitch is going to be 2 pi mv cos theta by qb. Right? I hope this is clear to you guys. Thank you.